If the base is omitted, we mean log base 10. Log base 10 is common to use, and so it's understood that it's log base 10. Now, I like to put the parentheses. That gets left out a lot because it is a function, but log base 10 of, let's say, b. Okay. So that's what we're dealing with today is log base 10, even though it doesn't make any difference as far as the proof of this evaluation. Now, y'all, it's tempting to use this result. This says the log of a quotient, but that's not this form. This is the quotient of two logs. So it's tempting to think you can use this result, but you can't. Now, let's take a look. What we did right here is just resort to the definition. In other words, every logarithmic statement, log base 10, has a corresponding exponential statement. And so what we can do right here is take advantage of that definition by rewriting this as 10 raised to the x power times 10 raised to the y power. Okay, now we got it in terra firma because we can use properties of exponents. In this case, we have the same two bases here. We have the same two bases, and so we can certainly add the bases. So that gives us 10 to the x plus y. Okay, just well-known properties of exponents. But notice we also have another way to represent this based on the definition of logarithms. This is equal to just the product of these two, what they call conjugate surds, I think. So you can write this as 23 plus 4 root 33. And you can already kind of see what's going to happen here. These numbers look nasty, but we have the difference of two squares formula to lean on here. Okay, and then times just what we call the conjugate of that rational or irrational number. Okay, so now again, folks, this is in the form of a minus b times a plus b, so we can write this as 23 squared minus this quantity 4 root 33 quantity squared. Okay, and that whole thing is squared. Okay, now I'll save you the arithmetic. This ends up being 529. This ends up being 528, and so this is actually equal to 1 here. Whoops. Let me get the eraser working here. Okay, so this is actually just 1. Okay. And again, this would be 5. This is 529, and this is 528. This would be 16 times 33, which is 528. Let me just write it underneath there if you don't believe me. That's 528. And this is 529. But you see, this is good news because what we get is 10 to the x plus y is equal to 1. Let me write that just right. Let's see, where can we do that? Let me come over here, folks. So what we have is 10 to the x plus y is actually equal to 1. Okay, so we end up with this result, 10 to the x plus y is equal to 1. But recall, folks, the only way an exponential can be equal to 1 is if the exponent itself is equal to 0. So in other words, the property you would use right here would be b raised to the 0 is always equal to 1. Just the properties of exponents, easy to prove. B raised to the 0 is always equal to 1, right? And so that means that x plus y has to equal 0. All right, but what does that say? Remember that the assignments that we made right here, 10 to the x is actually, this expression right here is just equal to x over y, right? X divided by y just by, from the definitions of converting a logarithmic statement to an exponential statement, right? But we also know that x now is equal to minus y. See, I kind of love this. Sometimes you can just go back to first principles, the definitions. No special results or any high-powered tools are necessary right here. So this would equal to minus y over y. So y there, ladies and gentlemen. Minus y over y. And that's equal to negative 1, which is the answer to the question. Okay, so folks, there we go. We are done. And notice, folks, that you may wonder, well, can y be equal to 0? No. Remember, 10 raised to any power. Just the shape of the exponential graph. 10 raised to any power, we'll just say b if you want to again. 10 raised to the b is always greater than 0, right? And so y and x are equal to 10 raised to some power. So this y can never be equal to 0, so we don't have to worry about a division by 0. And this is the final answer. Hope you enjoyed.